Alright, so for example 1, we take the vertices of triangle A, B, and C, and we want to find the image after the glide reflection. So a glide reflection is if you have a translation and then a reflection happening one right after the other. And so the line of reflection from each transformation is parallel to the previous image, and I'll show you what I'm talking about later on. So the first thing that I want to do is I'll take my original coordinates and I want to plot them onto my coordinate plane. There's my A at 2, 1, B at 5, 3, and C at 6, 2. I'm going to connect all my vertices together, slowly apparently. Okay, so the first thing that I need to do is the first rule, which is to translate the image with the rule of x minus 8 and y. So what I'd like to do always is write down all of my coordinates. There we go. And apply the rule to the appropriate coordinates. So then my x coordinates were shifting to the left since we're subtracting 8. And we're going to keep the y exactly where it's at. So then the image after the pre-image, after we apply the rule for the translation, should be A prime, which is negative 6, 1, B prime, which is negative 3, 3, and negative 2, comma 2, which would be C prime. So we're just moving the entire triangle 8 units to the left. So I'm going to plot those coordinates on the coordinate plane. There's A prime, B prime, C prime, and then connect them all. Okay, notice how nothing has changed. The size, the shape, everything about it, the orientation is all the same. We just glided the triangle from the first quadrant to the second. I'm sorry, the second quadrant to the first. Okay, so then next we have to reflect the translated figure in the x-axis. So our line of reflection is our x-axis right there. Okay, so we want to reflect the translated image in the x-axis. So I'm going to write down my coordinates and then apply the rule of reflection in the x-axis. So if I take my original coordinates, the only thing I'm going to be changing is the y-coordinate. So again, that negative b is really called opposite b. So then A double prime, B double prime, C double prime will look as follows. So I have negative 6, negative 1 now. B double prime would be negative 3, negative 3. And then C double prime would be negative 2, negative 2. Perfect. So then my blue triangle should be reflected in the x-axis. So I'm going to graph all the points. A double prime, B double prime, C double prime, and there's my triangle. So what I was talking about earlier about the line of reflection being parallel to the previous image, the green triangle is the new image, and the pre-image, the line of reflection is going to be parallel to, I guess, the image in the pre-image. And the one before that, if you look at the red triangle, the line of reflection is also parallel to its new image. So a glide reflection is what we call this composition when we have a translation and then a reflection occurring one right after the other. So the coordinates of the glide reflection is basically what we've written down in green right here. Okay?
Okay, example 2. In the diagram, the coordinates of the triangle ABC are given. Describe the composition of transformations from triangle ABC to A prime, B prime, C prime to A double prime, B double prime, and C double prime. Write each rule for each transformation. So, where do we start? Well, first of all, we want to identify our pre-image. So that is going to be the triangle that I outlined in pink. Now, why is it that triangle? I know it's that triangle because it does not have the prime, so that is the pre-image. So, then what happens to that triangle? Well, triangle ABC is then transformed of some type, we don't know yet, to the teal triangle that I highlighted. So how do I know that that is the next triangle? Well, because each of the letters only have one prime. So that means that's the first transformation that's performed. So triangle ABC goes to triangle A prime, B prime, C prime. So now we need to do some investigating and figure out what happens. Well, it looks like that triangle ABC is sort of flipped. It's the opposite of what it is. And what does it look like it's flipped over? Well, if it looks like that it's almost folded across the x-axis. So that is going to be, anything that is flipped is what we call a reflection. And since it's reflected over the x-axis, we call this an x-axis reflection. So that is the first transformation. The second transformation occurs when our triangle A prime, B prime, C prime slides over to that orange triangle over there. So how do I know that that comes next? Well, it's the only one left, but also because the letters on our coordinate grid have A double prime, B double prime, C double prime. So that means that that transformation is done after it is reflected. So we are looking for what happens from A prime, B prime, C prime to A double prime, B double prime, and C double prime. So what happens? Well, it looks like it was just slid across the coordinate grid. So something that slides over and doesn't rotate at all, that's what we call a translation. So how is this image being translated? Well, I'm going to pick point A to compare. So I'm starting with point A prime, and I'm going to look to see what happens to get to A double prime. Well, it looks like that it goes right 1, 2, 3, 4, 5, 6, and then from there it goes right 6, and then up 2. So if this is a translation, we need to write this in our translation rule form, which means that xy goes to x plus 6, x's are right and left, and that should be a y plus 2. So that's our two composition of transformations. We've combined two transformations. So our first one is the x-axis reflection, and our second is the translation of x plus 6, y plus 2. And that is your answer. And that's all, guys.